Okay. See, UPS systems we have been using in our office, in our homes nowadays. All homes is having a UPS system. See, in the software companies, IT industries, UPS is they called what is that? Heart is a heart actually. So because something is goes wrong, how the in the CPU in the computer the CPU is the heart of the system. Like that in the entire IT industry or IT building, UPS is the heart. If UPS goes, entire thing is goes off, right? So initial stage, there are step by step UPS has been innovated, starting with inverter, then offline UPS, then online UPS, then parallel UPS has come. Like different UPS based on the technology innovation, it keep happening. So when you talk about offline UPS in the sense it comes only during the emergency. There is a breakdown when continuous grid power is available. That time UPS interrupted power supply not available. Whenever the grid power off or grid power not available, then UPS will come. So during that the battery backup will come. So during that time there is a uh, power off, power drop, and then it will reconnect. So UPS in the entire system is nothing but energy is being stored in the batteries. Whenever the interruptions happen, that time that battery source will be used as a power resources. You all know UPS is uninterrupted power supply. That is a basic full form. As a maintenance executive or even the senior level, uh, we should have a well knowledge about UPS because any given time if something goes wrong you should be able to narrate, you should be able to analyze what the issue, where the issue, and how that technically we should able to explain. So that's what the intention of this session. So if you see first one is offline UPS, whereas utility source is there, that is grid power, then EMI or RFI filters, that is surge protector, then come to ATS, auto transfer switch, then load. So same parallel one line connected to rectifier, then battery, then inverter, and to a auto transfer switch, it going to load. So in this scenario, only in case of power failure, this auto changeover switch will switch off from grid power, utility power, and switch connect to the inverter side, so that there will be drip in the load, then reconnect. That is called offline UPS. Even our home internet, home inverters also is nothing but a offline UPS. Okay. Then come to static bypass. Static bypass in the sense it is nothing but an online UPS. There is a rectifier. Rectifier, it will be basic concept AC to DC conversion, because DC is required to charge the batteries, as well as you cannot feed directly DC. Again, you have to then inverter it will come. Again, from DC to AC conversion will happen, then it will go to load. So you may think why directly AC to DC conversion, why can't a direct flow it can be given? So that will be these are mainly grid power is not sustainable power. There is a voltage drop, there is a voltage unbalance, even sometimes low voltage or high voltage. So our output side, load side should have a constant voltage. That is the intention. You should have a constant and sustainable voltage. For that, this UPS, this many rectifiers and inverter systems has been used, and these are major components we can call out. But in this there are multiple components. If you see any UPS system, how many like SCR is there, SCR, then IGBT system, fuel system, each phase having a separate system. You have we're able to see in the UPS system, UPS panel. Same configuration, they simplified input rectifier and output is inverter. In the middle, they connected battery backup. Battery backup also connected to the SCRs is a gates electronics component, a power that is called power electronics. As I These power electronics operated on micro milliseconds. So in case of grid power fails, then battery voltage will be always available. Charging and discharging is any given time, it will be available in the inverter side within 300 milliseconds. 300 milliseconds from battery voltage, it will give the continuous power. So that will not give the any interruption. Anything above 800 milliseconds, any interruption happen, then it will disconnect the power. It will be interrupt will happen. Anything less than 800 milliseconds, any changeover, it will not give the interruption. Means that will not do, break the cycle. The sine wave cycle is that will not get break. So that's why this UPS system has been using. You can see static bypass is a standalone or single UPS configuration from rectifier to battery backup. Battery will get charged and again it will come back to inverter, then go to load. In case something happen here, inverter side, some failure, in case rectifier side something goes happen, faulty or any alarms triggered, it will goes on battery mode. Battery will take the load. So in case battery will have some backup time, probably uh, less than 5 minutes, sometime based on the load, 10 minutes, 15 minutes also, it will give the backup. Once backup is over, anything, nothing will happen. It will go to, in case of bypass mode. Bypass is connected, again, grid power. Generally, they'll not advise a normal grid power is connected to bypass. So it'll sometime it will connect it. Otherwise, it will go to, in case of parallel configuration, it will go to other UPS. So good part is in case of this remote control, remote RTC panel you call it, a remote monitoring system. If you have a remote monitoring system, we'll come to know whether inverter anything abnormal happen in the UPS, that will give alarm and person can able to come. If nothing is there, unless if you go physical inspection, you will not able to identify what's happening or what went wrong. So the static bypass is given, but in our IT industry is not advisable because of uneven power or uneven interrupt. Even that also can goes off. Okay, then come to parallel UPS. Okay, see now all the office got parallel UPS because parallel UPS is the future. In that we can have multiple standby options, then it will avoid the downtime. So if it's single standby UPS, standalone UPS, there will be chance of failure. But parallel UPS, there is no chance of breakdowns because in case of one UPS stripped, other will take the load. So you can see how the configuration connected. These are the same as all individual UPS system is there, like rectifiers, then battery mode, battery charging, discharging inverter, then output. Again, another one UPS, rectifier, battery charging, discharging inverter, and connected to output. Generally, output will be have one electrical system, electrical panel, or each you can say one synchronizing panel kind of things. Here, all the this UPS output, this UPS output. So in the parallel configuration, main agenda, three things should match. One is voltage, one is frequency, one is I think power factor. So these three things should be matched. Then only this voltage will get voltage will match it, and all three things match. Then only this configuration will be uh, output will be enabled. Because any one UPS will have a master and slave kind of things that will keep monitoring the all the three UPS output data, and accordingly it will sync it. Otherwise, this parallel will not happen. It will maybe trip the UPS. Then output panel have a single panel. Then from there output feeders will take out. So in this configuration, in case of any one UPS fails, imagine UPS one has some issue. Either in this scenario also rectifier having issue, UPS will goes battery mode. After some time battery discharge, then this UPS goes off. That is a basic configuration because in case of inverter trips, then it will not go to battery mode. It directly transfer the load to other UPS. Here, if in case in rectifier fails, then it goes battery drains, then inverter will get off, then load transfer to other UPS, then this will take care. Again, if this UPS also having some issue, then something goes wrong. Then here in the static by parallel UPS, uh, manual bypass or maintenance bypass will not be enabled. Generally, maintenance bypass will be there, but standby is not, it will not be enabled because some other technical reason it will not be it will be enabled. It will only either UPS 1 or UPS 2, then it will give the output. So this like number n number of UPS can be configured, 5 6, probably maximum 5 6 UPS can be configured based on the different capacity and different technologies available. Okay, in this overall UPS we can think over online, offline UPS, online UPS, then it will come to parallel configuration. In nowadays, we all know most of the people talk about modular type UPS. Our conventional type UPS have some technical glitch, some technical lagging. So that's why this modular type UPS has come to the picture. Modular UPS in conventional type UPS, only problem is in something goes wrong, entire UPS will be off. Okay, we cannot, it will not be degrade the load, but complete UPS will be get power off. But what is the one good advantage in parallel UPS? In case any something goes wrong in the, sorry, in the model type UPS, the particular model can be removable. Then is like a plug in and plug out kind of things. You can remove the model, and only thing it will derate the kilowatt hour. The capacity of the UPS will be reduced. Otherwise, UPS will never goes off. That's why nowadays people are using single UPS. There is no standby, there is no parallel operation. If it's the 500K UPS, they'll use the standalone 500 kVA model type UPS because it will never goes off. In case something happen, one or two model fail, that will be removed and reconnected. Then it will continue to run it. So this avoid the cost and avoid the space, avoid the battery backup. There are a lot of advantages considering the criticality of our load side. This configuration has been using. Okay. So with this, I am going to stop and we'll go directly question and answer session.